Yes, we need to write the absolute value of b. We would not need to write the absolute value of b if this were b to the 12, because 12 divided by 6 is 2. And as we know, b squared, no matter, sorry. So the 6 root of b to the 6 is indeed the absolute value of b. This requires the answer to be positive, and b could be negative. But, so this is a counterexample. If we have 12 divided by 6, which is 2, b squared is always positive. B is not always positive. We are told variables can be anything. But b squared will always be positive for any real number b. So here we need the absolute value, here we do not, because the answer is always positive. The last three don't have any variables, so the square root of 25 divided by 49, and then the square root of 1/4 with minus in front, and then the square root of negative 1/4. So let's discuss all of them. So the first one is easy because we know we can split the radical. So when you split the radical, the square root of 25 is 5, the square root of 49 is 7, and you're done. Of course, you're not going to use the absolute value on a number. Now, the same thing here is the same procedure. The square root of 1 is 1, the square root of 4 is 2. But we have a minus in front. Okay, fine. Now, let's discuss the square root of negative 1/4. Because the square root of negative 1/4 is a totally different story. And as we just discussed today, I have to split the radical into negative 1, the square root of negative 1, and then the square root of 1/4. I know the square root of 1/4 is 1/2. So this is square root of negative 1 times the square root of 1/4. I know that this is 1/2, and I know that this is I. So this will be 1/2 I. And there is no other simplification or step. See if you have any questions on this.
Does it matter which side the I goes on?
Very good question. It's like you can think of it as a variable. Do we write x times 2, or do we write 2 times x? It's the same idea. We know I is not a variable, but when we write it, we also put we always put the letters following, or the letters follow the coefficient. Do not precede the coefficient. Is it a mistake to write I times 1/2? No. Is it a mistake to write I over 2? No. They're all correct. But because we don't write this, but we write this, so we keep the same. But it's not a mistake. This is not a mistake. Reversing this order, these two, it's not a mistake. It's the same thing. Because we know that 2 times x is x times 2. Very good. Good. Now we're asking us to convert the 6th root of 6x into a rational exponent situation. I recommend rewriting it first as the 6th root of 6 times the 6th root of x. Because if we don't, then we will have to write parentheses, and then we will have to split the parentheses. But I think it's easier and better if we split the radical from the beginning. So, how do we convert the 6th root of 6 and the 6th root of x into an exponential notation? So the first one is 6 to which power times x to which power? Which power is the 6th root? It's the same thing with the square root. It's the same thing with the cube root. Same idea.
Just to the first one.
But remember, a radical is an exponential notation with an exponent that is a fraction. It's a special.
one.
Say it again.
Right. 1 over 2.
But the index is here.
6.
1 over 6. Indeed.
Yes, my mind went blank.
That's okay. That's why we are here. That's why we discuss all these things over and over. That's why I record everything. Because I know it takes time. Good. Very good. I lost you guys. I don't know where you are. I have so many windows open. I lost you. Oh my goodness. Okay, I found you. I closed everything because I couldn't find you. Okay, where is my test? Right here. Good. So now, simplify each of the following. Assume that all variables are positive. When the problem says that, it means don't worry about the absolute value. Okay? So we have the square root of 18x to the third. And then I'm going to copy all three. The square root of 2x, the square root of 6x, and then the square root of 54y to the fifth over the square root of 3y. Good. So how do you split the square root of 18x cubed? So we can fully simplify it. Anybody, please? We've worked on these problems, so let's continue working on them. I cannot take the square root of 18, so how do I split 18? It's a product, of course. I need a perfect square. Why perfect square? Because the index is 2. I need a perfect square and not, one that is not.
Did you do 9 and 2?
Yeah, of course. The square root of 9 times the square root of 2. Excellent. Now, how do I split x cubed? Because 3 over 2 is not an integer. Perfect. Remember how we do it. 3 divided by 2 is not an integer. We go back 1. And that is an integer. So x squared times x. Of course, the square root of x. So I split x cubed into x squared and x. Because I can take the square root of x squared, but I cannot take the square root of x. So this becomes 3. This becomes x. It should be the absolute value, but they're telling us everything is positive. So 3 and x go outside, and I regroup these two as the square root of 2x. And this is it. Any questions on this problem? Okay, so here we're asked to multiply these two. What would you write? The radicals have the same index. We can multiply them of what? It's a single radical of what? Applied to what? A single radical applied to what? What quantity do we have here? When we multiply these, what do we get?
12x squared.
Of course. Now I have to split 12 somehow. The x squared is fine, but I have to split this 12 in order to simplify.
4 and 3.
Exactly. Exactly 4 and 3. This is 2. This is x. It should be the absolute value, but they're telling us that everything is positive. And I regroup. I put the 2 and x in front, and the square root of 3 is the square root of 3. Excellent. Good. Like I did here, under one radical, I have to do the same thing here. So I'm going backwards, writing it under one radical, because the same is the same radical. So I have 54y to the 5th, everything over 3y. That's the first step. I'm going to move on to the next page. Okay. First, I have to simplify under the square root. Can anyone give us the simplified form under the square root? Anybody, please? When we simplify both by 3, what do we get? 54 divided by 3 is?
18.
Excellent. Y to the 5th over y is y to which power?
4.
Excellent. I'm happy with y to the 4th, but I'm not happy with 18. And we just had 18 a few minutes ago. You told me it's the square root of 9 times the square root of 2 times the square root of y to the 4th. 9 times 2 times this is this. But this now is 3. This is nice, 4 over 2. And this has to stay. So we have 3y squared, the square root of 2. These radicals are not fun, but they're like a little puzzle. Once you see it, you cannot really unsee it. Okay. Convert each expression to radical notation. So now they are going backwards. So we have negative 49 to 1/2, and then the other one is 49 to negative 1/2. So let's work on the first one. No one can touch the negative sign. The negative sign is outside. The power is the first priority. I can't do anything before I decide about the power. So the negative stays outside, waiting patiently. So now how do I rewrite 49 raised to 1/2? Again, when I see a fractional exponent, I know it's a radical. When I see a radical, I know it's a fractional exponent. So I see a fractional exponent. I know it's a radical. What is it? Radical of what? And what index?
Well, you don't write 2, so you just write the square root, right?
Exactly. The square root of 49, which I know it's 7. With minus in front is negative 7. Very good. Excellent. Now here, first I have to address the negative power. I'm not afraid of a negative power. It just signifies something. That's all. What does it signify? any negative exponent, whatever it is, it's basically what? What does it mean, the negative exponent? The negative exponents really do what? They represent a notation. Which notation? A negative exponent is a simple notation. What do they represent?
Is it 1/49?
That's it. Exactly. We just talked about 49 to 1/2. So therefore, this is the square root of 49. So this is 1/7. That's it. That's all there is to it. A negative exponent signifies a fraction. Question 5. So let's look at this graph and determine the domain and range. And is it a function or not? Is the first graph. Is it a function, and how do I determine whether it is or it is not?
Vertical line test.
Very good. By the vertical line test, this is a function. The same thing with the second one. Both are functions by the vertical line test. Excellent. So in both cases, they're asking us to find the domain and range. So for problem 5, can anyone help with the domain? And then for problem 6.
Bracket -3, comma, infinity.
This is it?
Parentheses.
Yes, excellent. And the range?
Bracket 0 to infinity.
That's it, absolutely. So from the leftmost point till the rightmost point, from the lowest point till the largest point. Okay, perfect. Now let's look at 6. So here's 6. The same thing, domain and range.
Bracket 0 to infinity.
No, there is no arrow.
Oh, it stops.
It's 0 to,
To
yes,
3.
No, 3 is the y value. We're talking about the domain. Domain is measured on the x-axis, from the leftmost point till the rightmost point on the x-axis. From 0 to 4. But it has to be with an open. It's an open point. Because it's an open point, we have to put a parenthesis. Good. Let's identify the range for this one. From the lowest y value till the largest y value on the y-axis. From the lowest y value.
0 to 3.
Exactly. 0 bracket, 3 parentheses. Because 3 belongs to the open point. Graph this by plotting points, present the table. I'm happy with 3 minus, so y equals 3 minus the absolute value of x. I'm happy if you just look at the graphing calculator. Because in the next course, you're going to talk about transformations, and that's a better understanding of the graph than just plotting points. So how do we do this with the graphing calculator? We go to y equals, we clear, and you just put in the function. 3 minus, the absolute value is under math. Click on math, scroll to the right to numbers, and it's the first one at the top, the ABS of x. Now, how do I use the so-called standard viewing window? Meaning, again, let me explain what the standard viewing window is. Sometimes the standard viewing window works, sometimes it does not. Depending on the function, you may have to adjust. but the standard is negative 10 to 10, negative 10 to 10. That's what it means. Negative 10 to 10, negative 10 to 10. That's the standard viewing window in the TI-84. Standard viewing window. Standard viewing window. So I go to zoom and I select 6, standard. And here's the graph. Okay. Good. In the next problem, we are given a function. And the function is x minus 2 over 9 minus x squared. They want us to identify and determine y of 2 and y of negative 3. So this is what I would do. If you give me this problem, let me just start a new video.